that the previous session is clear to everyone, as no one is asking any question. So in Hive modeling, we have three things. We have tables, we have partitions, we have buckets. Okay. So components, you can either can say Hive components or Hive data models. Now, first thing is tables. Just raise your hand who all have studied SQL before. How many of you have studied SQL before? Asatishi, please turn off your camera. Okay. Gunindro, Rajitsan, Manish, Achan. Those who have not studied, see. Okay. So see, when you work with SQL, first what you do, you create database and tables. Okay. So these are here in Hive. When you create tables, it will be very similar to SQL. Okay. First, you have to define metadata. Metadata means schema you have to define. Okay. Means you have to define how many columns will be there in your name of the column, name of the columns, and the data type of column. What does it mean? The data type you have to define means suppose you have a column student ID. Okay. So it's normal that it will be of integer type. Okay. If you have a salary as a column, so it's considered that it will be a float type. So data type also you have to mention. So all those information will come under metadata. Okay. So metadata you have to create first. Now here when you are coming from SQL to Hive, so you will see that there is a slide in table. We have managed table and we have external table. Managed table are also known as internal table. Let's see what is the difference between them. Okay, so when you are working with Hive, what you have to do first, there will be some data, okay, that you need to store into your HDFS. Our first step, that our data needs to be in HDFS. Yes or no?
Yes, ma'am.
Yes. Yeah.
Now, firstly, you will put your data to HDFS. Another thing, what you will do, see, in your previous session, you have seen this term, this command line interface and this web interface. Here, what we do, we write the queries and execute them. Okay, so similar thing, after putting our data in HDFS, what you need to do, just go to your Hive terminal. Okay, let's say I'm using that command prompt, that command line interface. I think there is some message. Shrikant, am I still not audible to you? Shrikant, kindly acknowledge. Okay. Okay. So see, first thing what we have done, we have put our data into HDFS. Next thing, we will go to our Hive terminal. Let's say we are using the command prompt. Okay. Now there, what we need to do, first we will create the metadata. Okay. Syntax we will give that this will be our table name. This will be these will be the columns and this will be the data type. Okay. Doing this after creating this metadata. Okay. So M here denotes metadata. After doing this, what we will do, we will load the data from HDFS into our Hive. Okay. So whatever data we have in our HDFS, we will load that data into this metadata which we have. Okay. So this is how our table will be created. That table will be considered as a managed table or internal table. Okay. Now, let's see what happens with the external table. So external table, first step will be same. Firstly, we will have some data that we will put into HDFS. Okay. Consider this is HDFS. Okay, not good with drawing all those things. I hope this is understandable. Okay. Another thing, we will go to our Hive terminal. HT is Hive terminal. Now, in Hive terminal, first we will create the metadata. Okay. So let's say I created the metadata. Now here, when you are creating metadata, now while creating the metadata only, we will write one line which will say that my data is present at this point. Means we will give a pointer like thing. We will reference by saying that data is present here. Okay. So this load we will not do. Means in internal table, what we were doing, we were loading the data from HDFS into our metadata. Here, instead of doing loading, what we are doing, we are giving a reference. We are giving a pointer that our data is present at this particular page. Okay. Now, okay, why these two types of tables are required now? Let's see the advantages or disadvantages. Okay. So suppose now you are in an organization and you are working with a team. Okay. Now, on one particular data, it is obviously that there will be more than one team member will be working, right? Now, suppose a new person comes, or maybe suppose an old team member is working. He or she unintentionally, or you can say intentionally, deleted the data. Okay, from the Hive. Okay, means after this, suppose I have issued the drop command on that table. Okay, and here also I have issued the drop command. Maybe intentionally or unintentionally, mistakenly. Okay. Now what will happen if I issue the drop command over here? Then I will completely lose the data. I will be completely lost the data. How? See, first the metadata will get deleted. Okay. Another thing, since we have loaded the data into this metadata, loaded means our data now moved from HDFS to the Hive. Okay. Means here we not contain any data. Also, we have dropped from here. So at the end, if I issue the drop command, I will not be having any data. Okay. But when we talk about external table, in this case, what happens? If I issue the drop command, my metadata will get deleted. But my data which I have stored in HDFS will still be there. Why? Because in this case, I have not loaded the data from HDFS to my Hive, to my metadata in Hive. Okay. I have only given the reference that my data is present over here. So in this case, if I issue a drop command, then my data will still be there in HDFS. Okay. So in any case, I don't want to lose my data. That I need to analyze, that I need to query. So in any scenario, I can't lose the data. This is why external table was introduced. I hope the difference between internal and the external table. This internal table means this managed table I'm talking about. I hope this is clear.
So in managed, like in internal, we are loading it to Hive, and we are like overwriting the data somehow, maybe.
Not overwriting. You know that cut and paste or move.
Yes,
Okay.
yes.
It is doing the same thing. Okay, we are moving the data from HDFS into Hive.
Okay.
Okay. Or you can say that we have cut the data from here and pasted it over here.
Yeah, okay.
So now I don't have data in HDFS. Also, I have issued the drop command, so I will lose the data from here as well.
Yes. Okay.
Okay.
Yeah.
I hope this tables part is clear to everyone. Don't worry, we will see practically as well how to create this table. But before that, theory is important. Okay. So that implementation, you will be able to understand what you are actually doing by writing these queries. Okay. Now, let me delete all those things. Let me discard it first. Queries. Okay. Mhm. Okay. Now let's understand partitions and bucket. Okay. So partitions we do when you write the queries. If you remember SQL, when you write the queries, okay. Suppose you have a data set of a university. Okay, maybe of engineering department. Okay, engineering department. Let's say all over India. Okay. Or you can say all over world engineering department. Okay, now in that engineering department you will have those CSE department data as well. You will have mechanical, electrical, IT, and different other departments. Okay, now suppose I want to see the data. I want to see only data of the CSE department. Okay, now if I run the query that select star from suppose that student table where department equal to CSE. Okay, I want to see only the CSE department data. Now what will happen if if I'm saying that I have this all over the world, I have this engineering data, engineering students data, then my obviously my rows will be in lakhs or more than lakhs. Okay. Now, if I run this query, this where department equal to CSE, what will happen to each and every row? It will check if the department equal to not, and it will fetch the data accordingly. Right. Now, what will happen in this case? It will take large amount of. Okay, when we are saying that we are dealing with big data, it will have millions of rows. Okay, billion of rows. Okay, so what it will do to each and every row it will match if the department equal to CSE or not. Okay, and then it will fetch the data, which will be very time taking. To avoid this, okay, to make your process speedy, partitions concept was introduced. Okay, means we will partition our main table into subdirectories. How? Let's see this example. Okay, suppose we have a main table named as student details, and in student details, let me create it. We have our main table student details, and in student details I have columns named as student ID. Very difficult to write. Oh, is SID means student ID. Okay, then I have a student name, then in which year he has enrolled, from which batch he belongs. Okay, then I have a department as well. I have I'm only a small number of columns are there. Only 4 columns are there. Okay, student ID, name, year, and department. Now it contains billions of rows. Suppose it contains billion of rows, and there will be a student from different departments. Now, if I write a query that selects students where department equal to computer science engineering. Okay, now what it will do, it will go to the first row, it will match. If the department matches, it will fetch the result for you. Okay, it will go to another row and another, it will match if it is matches or not. If it doesn't matches, it will go to the next, and so on. It will go to each and every row. We are introducing the concept of partitioning. Now, what the partition do? Let's suppose we will take one column, and based on that column we will partition our table. Okay, so suppose So suppose you take this depart column as your partition column. Okay, like based on department, I want to partition my table. Then what will happen? It will go to it will go to each and every row of the department and fetch the unique values. Okay, because there will be several students who belongs to CSC department, means CSC will come several times. Then there will be several students who belongs to civil department, civil will come several times, and so on. So it doesn't mean that if civil is coming 10 times, it will make the columns 10 civil, okay, or 10 civil folders. It what it will do, it will fetch the unique values from this column. Okay, see, suppose we have only, let's suppose we have only 3 CSE, another is civil and another is electrical. So what it will do, it will create 3 subdirectories. Okay, means from this table 3 tables will be generated. Okay, 3 subdirectories will be generated. One subdirectory will have CSC department, and in CSC department all these columns will be there: student ID, name and year. Okay, these 3 columns will be there. Then another subdirectory will be of civil department, and it will contain student name and year, and student name and year will belong to department civil, to that particular subdirectory. Okay, similarly we will do electrical as well. Okay, so 3 subdirectories formed. Now if you execute the query, okay, where department equal to CSC, what it will do, it will only search the subdirectory where department equal to CSC. Okay, so our execution time will reduce now. Okay, it will our execution time will reduce now. This is the advantage. Now I hope partitioning is clear. Can we move to the bucketing now?
Yes, ma'am.
Okay, now bucketing or partitioning, you can say that the motive is same for both of them. Okay, to make it more manageable and to make it more speedy. Okay, but why bucketing is introduced? Suppose you have this department. Okay, in this department, in CSE department, there will be students. Okay, who will be working. So in suppose in CSE department, I have the attendance data of student. Now, an attendance data is on the basis of date wise. Okay. Now, if I search by date, what will happen? If I search by date and if I partition by date, what will happen? There will be too many partitions. Okay. So what I want to do, and also the CSE department will contain lakhs of rows. Okay. So I want to have buckets, or you can say sub files, which have similar type of data. Okay. So what I do in that case, I will do the bucketing on my partition. Okay. Now, understand one thing before understanding bucketing, that suppose you have a main table. On main table, you can do partitioning. Okay. And there will be several partitions based on the unique values in your column. Okay. It's not necessary that there will be only 3 partition. And on partition, you can do bucketing. Okay. And bucketing will be as the number you suggested. Suppose you have say I need 10 buckets, so there will be 10 buckets to every partition. Suppose I have said 2 buckets, so there will be 2 buckets to every partition. Okay. Another thing is, okay, 2 buckets. The thing is, suppose you have a main table, and on the main table directly you can do the bucketing. Okay. And suppose you want 2 buckets, so there will be 2 buckets. Now, how bucketing will happen? Let's give me a minute. Okay. Now, to bucket your to make it in a more manageable form, a hash function will be used. Okay. Suppose I have this partition now. Okay. In my partition, suppose I have a department which is CSE. Okay. Now, in CSE department, I want to do the bucketing. Okay, and in bucketing also you have to first specify 2 things: on which column you want to do the bucketing, Like we have first defined on which column we want to do the partitioning. We have selected department column for do the partitioning. Here also, when you are doing bucketing, you have to define in which column you want to do the bucketing. After that, you also have to specify how many buckets you want. Okay, so suppose I have in my partition, I have this data, this student ID, okay, this name and this year, another column year. I want to I want to do bucketing based on the column student ID, and I want 2 buckets. Okay, so how the data will be segregated? Suppose my CSE document contains 10 rows. Okay, I'm taking only of rows. Okay, there will be a huge number of rows. Okay, so there could be lakhs of rows. Okay. So I'm choosing the student ID as my bucketing column, and I want to segregate it into 2 buckets. Okay, suppose I have 1 lakh rows. So how the data will be segregated? So there will be a hash function used. Okay, hash function will be such that, like, first you have to write student ID. Okay, this is this as student ID modulus this. Okay, the number of buckets you have defined. Suppose I have said 2 buckets, so I'll say student ID modulus 2. Whatever be the answer you will get, that particular row will go onto that particular bucket. Okay, suppose I have student ID as 1. So what it will be? 1 modulus. What is 1 modulus 2?
0.
1 modulus 2 is 0. What is modulus?
The remainder.
It will give the remainder. So it will be 1, right? I hope this is clear. Hash function 1 modulus 2 will give 1. Everyone is getting the same. Explain that as well. Are you getting some different answer? No, please let me know. So then only I'll explain. Otherwise, I'll just move ahead. Everyone knows this 1 modulus 2 will give me 1. Okay.
Yes.
Suppose I have 7 modulus 5. What will be the answer?
2.
2. Yes. Okay. The remainder will be the answer. So here I'm getting 1. But now my this student ID 1 will go to the bucket 1. Now suppose I come to student ID 2. Okay. So it will be 2 modulus 2. Remainder will be 0. Okay. Means my student ID 2 will go to the bucket number 0. Okay. It is 1 or 2 written. Let's make it as 0 and 1. Okay. So likewise, my rows will be segregated. Now suppose if I have the repeated values in my partition table. Partition, I have repeated values. Now what will happen when I function? Suppose I'm getting student ID several times. Or you can say if I have this unique value, then what will happen? When I'll get this student ID 1, it will always fall onto the bucket number 1. And whenever I'll get student ID 2, it will always fall into the bucket number 2. Bucket number 0. Means those buckets will have the similar type of data inside them. Right or not? Clear? Still, if it is not clear, what I'll do, I'm sharing one link with you all. Okay. Because since I do not have a table right now, I'm sharing a Stack Overflow link with you. There, just see one example. It will be the answer is given. I'll tell you. Wait, I'll share the link with you. Your group name is. Your WhatsApp group name is. Nobody remembers.
PTT classes.
Okay. Another one I'm sharing with another group is which groups? No. Okay. Do one thing. Everyone open this link. To make it more clear, I'm sharing this link with you. Okay. I'll share my screen with you. I hope my screen is visible to everyone.
Yes, ma'am.
Okay, go to this explanation. This where 19 is written, and before going into bucketing, we need to understand pattern. So here what they have taken, they have this table as an example. Okay. So if anyone thinks that it is not clear by looking at the picture, consider this example and read these lines. If you want, I can explain these lines as well, what they are saying. I have said the same thing while I was explaining. Okay. So what they have done, suppose I have this table, okay, and they have taken a very small data set just for example, okay, here billion of rows can't be mentioned. So suppose if I write query like search data where product ID equal to P, what it will do? It will go to each and every row. Every row it will go and it will even to P2 and it will say, okay, it is not found, and then it will give you the answer. Now, just to avoid, so what they have done, they have done the partitioning based on this product ID column. Okay. So when they will write, now what will happen when if this partition will be created, so one partition will be based on the P1 and another partition will be based on the P2 because we have only two unique values over here. Okay, now if you apply the query where product ID equal to P1, it will only go to these rows, only go to this partition where your product ID is P1. Our time is reduced. Yes.
Yes, ma'am.
Another thing here, these cons and pros also study. This cons is like if you have the repeating values, okay, means you should not be used for the column where numbers of repeating values are very less. Okay, for example, if I'm saying, if I say there is a name column over here, okay, along with sales ID, product ID, transaction date, amount, there is a name column as well. Okay, maybe the name of the employee who sold all these products. Okay, now there you will see that the repeating values are very less, right or not?
Yes, ma'am.
Okay, now what will happen in partitioning? It will take all the unique values. Taking all the unique values means there will be suppose there are around 1,000 employees. Okay, so what will happen for 1,000 employees? There will be 1,000 partitions will be created, right? So is this a manageable kind of thing? No. You have to look of thousands of partition. It has increased your task instead of decreasing your work. right? So you have to do the partitioning on a column. You have to select the column such that it contains more repeating value. If you have more unique values, means means those many partitions will get created. Okay, and managing those partitions will be a tough task. Okay, and when you are doing bucketing, you have to choose a table such that it contains the unique values. Okay, like the sales ID. Okay, now when you are doing bucketing, you're now when you're now your table will be, your data will be segregated into files based on a hash function. Okay, so suppose I'm doing it based on the sales ID. So, and I want only two buckets. Let's suppose I want five buckets. Okay, five buckets, and I'm using sales ID as my bucketing column. So it will be 1 modulus 5, 2 modulus 5, 3 modulus 5, 4 modulus 5. Okay, and whatever be the answer, that particular row will go to that particular column. Okay. And if you want to do the bucketing on a partitioned table, then also your data will be in a more manageable form. Okay. So what I suggest, just go through this article once. This example is very beautifully explained. If you want, you can see other examples as well, because different persons elaborated it on based on different taken different example and explained differently. Okay, this example you will I think this will be more clear to all of you, as this we have a picture as well of the data. Okay. So kindly go through this. If you still face any difficulty between the differences between partitioning and bucketing, and why we are doing partitioning, why we are doing bucketing, do let me know. Okay, WhatsApp message, mail, or in the class. Okay.
Okay, ma'am.
Okay, everyone.
Okay. Okay.
Okay. Okay. I hope it is clear, but I'm just giving you another option. If it is not clear, just go through this article one more time. And still, if you face any difficulty, you can ask. Hmm. Okay, another thing, another issue I have already discussed one issue. When you use bucketing column as your string column, okay, suppose I'll share my screen again. Just give me a minute. Okay, I forgot to discuss about this. Suppose I have a column here. I cannot draw it over here. No? Okay, suppose I have column here named as name. Okay, and I'm doing the bucketing based on name column. So what will be my hash function become? Suppose name here is Rajathan. Okay, so what will be my hash function? Rajathan modulus number of bucket equal to whatever answer I get. Okay, now see, when you have integer type of values, you know how to what will be the result. But when you have this string type of data, then how you'll be able to get the answer? See, humanly, manually, you can't tell the answer. Rogers modulus 2, you will not be able to find the answer. Okay, there will be some calculation, or it may take you time. Okay, but it may take some time, and then maybe you will be able to give the answer. But the faster way, like 1 modulus 2, or 2 modulus 2, the way you are giving the answer in integer type, in string type, it will be difficult. Okay, so all those things you need not to worry about that, because this even if we have integer value, we do not do we don't do this hashing, all those things. This is internally happen. We only mention that we want to bucketing, we want based on this column, and we want 2 buckets, 5 bucket, 10 buckets. Okay, like that. We don't do the hashing. It is internally, this is internally happen. Okay, in Hive. I hope you all have understood what I'm trying to say.
Yes, ma'am.
Oh, okay. Now just give me one more minute. I'll share my screen again. So shortly we will see the practical based on all the three. And one more thing, that you can do the partitioning based on more than one column. And similarly with the bucketing. Okay, it is not necessary that you will partition based on a single column. More than one column is allowed. Now, while practical, I'll tell you. Now let's come to the next slide, which is Hive query language. So yesterday I have told you that Hive query language we use when we are working with Hive, when we are writing queries in Hive. So that will be called as HiveQL or HQL, which will be very similar to SQL. And we have seen the differences between SQL and HQL. Who will tell me the differences between SQL and HQL? Hmm? At least give me two differences between HQL and SQL. Okay, one difference is enough. Okay, let's come to the previous slide, but you have to tell.
In SQL, we can delete. We have the delete, but in Hive we cannot delete because yes, that's the difference over here.
Yes.
Due to the because we have to,
Transactional queries both can be performed in SQL, but in when you talk about HQL, only analytical focus will be there. Okay, that is why update and delete from HQL.
Yeah.
Right? Means
modification you can do. Yeah, right.
Okay. Now, what data we can handle in Hive? When it is best to use Hive? When I have streamlined data? Or when I have
historical data, I think.
Sorry, actually two since we're talking together, so I didn't hear the answer. Please repeat.
Historical data
Historical data
and well organized
structured type of data.
structured type.
Okay. भूल गए आप लोग नहीं? I think not every one of you is comfortable with him.
Historical data.
Okay. Now, this is just for the completion purpose, as I have already told you that HiveQL is SQL-like query language for Hive. Okay, so the query language will be called as Hive query language, HQL. It mostly mimics SQL syntax for creation of table, loading data into tables, and querying the tables. Okay, very similar to the SQL. HiveQL also allows user to embed their custom MapReduce script. Okay, means you can write those user-defined function. You can also call the Python scripts. Okay, from Hive, and all those things are possible when you are dealing with when you are writing HiveQL queries. Means if you are writing the code in Java, you can make it as a user-defined function and add it into your Hive and run your program. Okay, execute your queries. Similar thing, you can write your Python script and you can call your Python script from Hive. Okay, all those things we will see while practicing the commands. Give me a minute. Okay, Manish, you will get the recording. Okay. Now let's see the Hive data types. Okay. So Hive supports different data types, which can types to be used in table columns. Okay. Basically, there will be the primitive data types and the complex type. Okay, so primitive, when you talk about simple data types, when you have like integer, float, and very simple. We will see some of the examples as well. Okay, and when we'll be creating table, I have the examples of the primitive data type. Complex, when you have those arrays, structure, and all those things. Okay, so let's see here. In primitive, you have numeric type of data, means those integer, float. Okay, your decimal type of data. And when you have date and timestamp, okay, year, month, all those things. So you can use date and time data types. And when you have strings like name, address, phone numbers, all you can use them in a string data types. Miscellaneous type, when you have those Boolean types. Okay, means when you have yes or no answer, when you have 0, 1 value, when you have true, false value. So those will come under miscellaneous types. Okay. So these are the primitive data types. Then we have complex data types as well. Okay. So in complex data types, we have arrays, means where in you can store more than one element. Okay. So here the format will be, first you have to write array, and then inside array what type of data you will have. Okay, inside array you can have integers only, you can have strings only, you can have floats only. Okay, so that data type you have to mention first. Okay. Then for map, when you have the key value pair type of data, when you have dictionary type of data, when you have indexing type of data, okay, then you can use this map data type. Here you have to write map keyword, and then you have to write the key data type and the value data type. Your key needs to be of primitive type, and your value could be of primitive type or complex data type. Okay. Then we have structures as well, which is quite complex, you can say here. It's a lot. First you have to write struct, then the name of the column and its data type. Along with that, you can write comment as well. If along with the column, if you want to write any comment, you can do that. This is possible in structure. Okay. Then we have union. Union, you can say, quite similar to arrays, but arrays are homogeneous and union are heterogeneous. Now, what is the difference between homogeneous and heterogeneous? Means where first you see more than one element you can store, and every element can be of different data type here. Okay, but when we talk about this array, every element should be of same data type. Means if you have an array, it could only be of, if that array should only contain integers, or should only contain strings, or should only contain float. It should not be like one element is integer, another is another is float, another is string. It should not be like that, but in union it is possible. Okay, I hope this is clear.
Yes, ma'am.
Okay, now the limitations we will see. First we will do all the practical parts. So let's we have 10 minutes, so let's execute very simple queries today, and hopefully we will write the complex one tomorrow. Okay. So let me just open VMware first. Loyaba is there in the session? Loyaba, are you there? No? Okay. I hope you all are well aware of how to configure this Cloudera image into VMware Workstation.
Yes, ma'am.
Good. please keep that link which I have shared, overflow link, where difference between partitioning and bucketing is given. Okay, you can go to each and every answer. You will understand, you will get something from it. Okay, and the answer which I have mentioned, and please go through with that answer. That will be more clear to all of you. Okay. It is open. Let me go to practical file. Okay, so if you want to clear the screen from HDFS, there you have only have to write clear. Okay, but when you are dealing with this Hive terminal, there you have to write exclamatory clear and the semicolon. Okay. I'll come to all those things, but let me first open this virtual machine. And Shrikant, I hope your problem is resolved, which you were facing in the morning. You still have few errors. Okay, let's see it after 4 o'clock. Okay. Okay, Shrikant. Store this data into HDFS. Okay. So what we will use, which command we will use to store my this file into my HDFS? Which command I will use to store this file onto my HDFS?
Copy.
Command? Yes.
I think it's
Command I will use, right? Okay. See, I have mentioned here there's some extra as well. This like RM command means suppose you have file already with the name sample.txt. So you can remove it first and then put it again. And one more thing, change your file name. Okay. Instead of sample, just give some another name. Then it will not give you error that file already exists. Okay. Then put this file. After putting using ls command, you can. Why we use ls command? To list all the files or the folders present into your HDFS, right? Now, what we will do, see, first we have created one file, then we have opened the terminal and run all these commands. Then what we will do, we will open another terminal as well for Hive. Okay, with one terminal we will use for the HDFS queries, another terminal we will use for the Hive queries. Okay, means HDFS commands and the Hive commands. Okay, So 2 terminal will be open. Now to enter into Hive, first what you need to do, you need to write Hive and then enter. Okay, let's see if my, okay, it gets open. So just give me a minute. I'm minimizing it. I'll come to this window as well. So how to open Hive terminal, I'm telling you, because I'll share one table syntax with you, which you have to execute. Okay, so right click, open in terminal. Mistakenly, I have closed it. So to enter into Hive terminal, just write Hive and execute. Enter. Okay. It will take some time and your Hive terminal will get open. And do one thing while it is executing, just open another terminal as well. And that terminal you can use for writing your HDFS command. Okay. So whenever you want to put or you want to list, you can use this terminal. Okay. So I have opened 2 terminals. Now, see, here I have written Hive and then enter. So all those things will execute, will give you some warning, and this Hive with the angular bracket will be visible to you. Means we have entered into our Hive terminal. Now here you can write your Hive queries. Okay. Now, another thing is, this is the command line interface you can see. Okay. We have also seen this web GUI based. Web interface. Remember, 2 terminal we have seen. This web GUI based and another is command line interface. So consider this as command line interface. Your web interfaces, just minimize it. Every time you open your Cloudera, this window gets open. Remember? So this is your web based. Here, what you have to do, you can go to the hue. Okay. Okay, here ID and password it will ask. The ID and password will be Cloudera for all of you. Okay. Then sign in. Okay, I'm just closing it. If you want to make it as remember, you can do that. I hope you do not have any session or lecture after my class, as I'll take 5 more minutes. Okay, then I'll wind up the session. Now, once you open your Hue, it will give you a similar type of page. Now here, what you can do, where query is written, just click on this drop down menu. Okay. Here you will go to the editor and there will be different editor available over here, like Impala is there, Hive is there, Pig is there, and many other terminal. Okay, since we are working with Hive, just click on Hive. Okay. Now here also you can write the queries and this will be the play button to execute your queries. Okay, so I'm showing you the 2 ways of executing your queries to query the data. This is the GUI based, and another one is this Hive terminal, which we have, where we have written Hive and entered into this terminal. Okay. So these 2 interfaces will be there where you can write your queries. Now, let's see how to create metadata. Okay, I'm showing here only on Notepad. Okay, tomorrow in the tomorrow's class I'll show you how to execute these queries, but step by step I have mentioned everything, so I hope you will be able to do that without my help. Okay, so let's do one thing. Let's write 1 or 2 queries here also. Okay, so you know that first we have databases. Okay, in databases we create table. Okay, so let's see if we have any database in this Hive terminal or not. So to see if any database present, means what are all the databases present here, our command is
Show
show
database.
show databases.
It's very similar to SQL. There also we write show databases, right? Okay, so it is showing okay, means query is successfully executed. Then I have CDEC as one database and test as one database. And this default one is by default on Hive. Okay, like if you open, like if you work with SQL also, you will see that there are some default databases. So this default database is that only. Then I have created CDAC and test, which are also visible. Okay. Now, if you want to create your database, you have queries for that as well. Okay. So using create database and then the name of the database. Okay. Then again, you can see if your database which you have created is available, is visible onto the list or not. And whenever you want to make any table, okay, what you have to do, you have to first write use test. Means I want to create my table into my test database. So what I'll write, I will write use test. Okay, if I want to alter any table which is present into particular database, obviously alter is not present in Hive. Let's suppose I want to select some fields from particular table. Okay, and that table present in some database named as test. So first what I'll write, I will write use test and then I will write the queries. Okay. So it is you can say a good way of writing the of creating the table, that first of all create the database, use that database and then create table. If you do not create the database and without using the database you are started creating the table, that will be in a scattered form. Okay, so the good choice is, the good option you can say is first create the database always. Okay, it is not there like if you will not create the database your table will not get created. Okay, but when you create the table without using any database, without creating in a database, your table will be in a scattered form. Okay, so write use test and then inside that create the table. Okay, now I think it's already 4:05. Let's do one thing. Let's do practical part tomorrow. For now, what you can do, I am giving you two assignments. First assignment is you have to understand the difference between bucketing and partitioning clearly. Second assignment is you have to search what are all the files which are supported in Hive. Okay, since we are going to work the CSV type of file, you have to search what are the other file formats which are supported by Hive. Okay, these two things you have to search, you have to understand. And those who do not remember what we have studied in yesterday's class, because when I was asking question, you were quiet. So please go through all the theory parts. Okay, tomorrow definitely we will go with the practical part. Okay, now if anyone have any doubt, please ask. After that, I'll take the queries from HDFS and MapReduce.
Ma'am, what's the first question? Repeat again.
First question, you have to see the difference between partitioning and bucketing. Link I have already shared. You can refer some other resources as well. Okay. So this assignment I'm giving you so that when you are implementing, when you are practicing the query, you should have a clear-cut idea why you are doing this. Good, Ashish. I have received your mail ID. Okay. Your another assignment is you have to search what are the different file formats which are supported by Hive. Okay. One I was using, which I have created a comma separated file, means CSV file format is supported by Hive. So you have to search what are other different file formats which are supported by Hive. Okay.
Yes, ma'am.
Okay, good. Now, if you do not have any doubt, you can leave the meeting. If you have doubts, you can stay in the meeting and can ask your question.